Hi everyone. In the given problem statement, we are given n cross n matrix and we have to return all the elements of the matrix in a spiral order. So here the question is very self-explanatory. Here from looking to the diagram, we can easily understand how our traversing of the matrices is to be done. So how to do it in a very effective manner? So here we have to return a list of all the values in which order we have traversed. So let me type in particles. Particles would be the value of the matrices. And let me define a function called spiral print. And here we are going to pass in two parameters m comma n. And this is going to be rl print is going to have a value of a length of matrix and length of matrix of 0. So we are going to send in the length of the rows and length of the columns. Now once we have it here we are going to initialize two more variables, which is going to be k, which is 0, and l, which is also 0 initially. Now if you look into the matrices, every time one traversal is done, the value of k is getting incremented and the value of l is going to get incremented too, but the value of m and n, see, when the first time when you're coming from the left to right, the row wise, 1 2 3 got printed, three values got printed, but when you're coming down, only 6 and 9 are going to get printed. Similarly, when you're coming from 8 and 7, two values got printed, but now when you're moving up, only one value needs to be printed because one has already been printed out. So let me do it in this way. While my k is less than m and l is less than n, in that case, let me give spacing for the readability. Now I'm going to loop in. So I'm traversing from the left to right. I'm traversing all the rows. So for I in range 0 to, okay, it would be L to N. And now particles dot append matrix of k and I. So now initially 1 2 3 would be going to get added to this matrix, and now once it's been added, I can increment the k value by 1. Similarly, now we are going to do a loop where we are going to come from the top value to the lowermost value, means we are traversing from the column wise. So for I in range k to m and particles dot append matrix of I and n minus 1, n minus equal to 1. Now a condition I am checking. Now if our k is less than m, because you need to check it up. So for I in range n minus 1 to L minus 1, and we are going to decrementing the values. So here we are traversing from the right to left row, so the value is going to get decremented. So particles dot append matrix of m minus 1 and I, and our m value is going to get decremented by m minus 1. Similarly, if L is less than n, in that case I'm going to loop through for I in range m minus 1 to k minus 1 and minus 1. So you can check in the conditions how these conditions have been added, and feel free to explore in case if you want can optimize this code. And now we are going to append the matrix of I and L, and we are going to increment the value of L by 1. Well, now once that is done, right, we can return particles. Now if I run this code, I hope there aren't any spelling mistake. Okay. Yeah, instead of spelling mistake, I made a mess of the loop, I think. So now again, let me try it up. Let me run it. Yes, the public test case is passed. Let me submit the code. As you could see, all the private test cases passed and our code got successfully submitted, and it is beating 100% of the submission, because if you look into it, right, here our time complexity is big O of n, which is pretty efficient for this type of problems, and our solution is very effective. Now let us jump to the next question.